As we move into section 1-3, we're going to be talking mostly about angles. So let me get one drawn up here and we'll get talking. The key to start with is that an angle is formed with two rays. So there's an endpoint for one of them. We'll call it the point A. And there's the point B. So there's a ray to start us off. Now we'll do a second ray. Starts at the same point here. A goes to the point C. All angles that we talk about in mathematics, physics, chemistry, all related fields, start with the idea of being two rays. And then this represents that angle that we've defined. Now by definition, an angle is a figure formed by two rays with a common endpoint. So that would be the definition of angle, a figure formed by two rays with a common endpoint. Right there. Now that endpoint we call the angle's vertex. Now the definition of vertex would be the endpoint is the endpoint of the two rays of the angle. Most people commonly call the vertex the corner of the angle, the point where it all meets up and turns, if you will. Now, this angle has a name. This is one of those things that we often blitz through that you cannot afford to not know how to get right because it's going to influence everything we talk about as far as angles go for the entire year. This angle's name is angle CAB, or we could call it angle BAC, or if it's the only angle on the page that has a vertex of A, we can just call it angle A. Now it's important to note with this, you'll notice that the middle letter is always the vertex. We always name our angle by going side, vertex, side. So this particular angle has names CAB or BAC. You really want to avoid using this unless you're in a very big hurry with your writing, because very rarely do we have only one angle at a given point. We often have multiple angles all springing off the same point at the same time. So it's important to keep that in mind. For example, say I were to draw two new angles there. Now I'll put some points up here. We'll call this P, Q, R, S. So here's the question. If I talk about angle S, am I talking about angle P, S, Q? Am I talking about angle Q, S, R? Or am I talking about angle P, S, R? You should see three individual angles there, three pairs of rays. Angle 1, angle 2, and angle 3. That's why the way we name the angles is so critical. Will I take points off on a quiz if you call something angle A when you really need to call it CAB? Yes, I will. If you were to talk about this angle right here, angle PSQ, and you simply call it angle S, will I take points off? Absolutely. Because I don't know what you're talking about. The language is the key. So you need to be speaking the same language as everyone else. So again, if I want to talk about this particular angle right here, I'm going to call that angle PSQ. Angles are measured in terms of degrees. That's how much it opens. We know from perhaps other classes that if I were to mark off a circle in these degrees, a full circle is 360 degrees. That's actually part of its definition. The four terms we use when referring to the size of an angle in this course are going to be acute. Those are angles which are between 0 and 90. Now, in this case, I'm just talking about generic angle A, because I'm only going to have one on my page. And that's an angle that is between 0 and 90, so perhaps that's angle A. And you can see it's a typical small angle we would think about. Now, notation-wise, M refers to the measure. Angle A is this guy right here. Angle A is a thing. The measure of A is a number. In this case, perhaps it's 60 degrees. So that would be acute because it's less than 60, greater than 0. A right angle, then, has a measure exactly equal to 90. We denote right angles by drawing a box in them to show that there's a right angle there. To say that it doesn't just look like it's 90 degrees, it actually is intended to be for all purposes. In some diagrams, it might not look like it's 90, but have the box, you have to believe it's 90. In some pictures, it will look like it's 90 degrees, but there's no box. Don't assume. That could be acute, it could be obtuse, it could be right. I don't know until I have a reason to draw that box in and make it 90. Obtuse. The way I always keep obtuse and acute straight is that obtuse is a word referring to things that just don't fit right, things that stick out. An obtuse angle does that. It's an angle greater than 90 degrees. So 90 less than measure of angle C less than 180. Now notice that when I'm talking about these angles, I'm using the idea of 90 to 180, but they're not equal to. It's strictly less than 180, because when I get to 180, I have what's called a straight angle. In fact, when I look at that, it looks like a pair of opposite rays. Because I've taken my angle, I've opened it up all the way to the point where now it's a straight line, where my two rays that made up the sides of my angles are now a line. If I continue to bend this around, I then slide back into having an obtuse angle until I go back to being right, and as I continue to swing my bars down, eventually I'll hit the point where I'm looking at an acute angle again. So again, acute, right, obtuse, and straight. When I talk about congruent angles, it's the same thing we talked about when we did congruent segments. Two angles are congruent if they have the same measurement. So here are two angles. I'm going to call this angle EFD and angle XYZ. As long as their measures are the same, this opening is the same number of degrees as this opening, then I say they are congruent. What this I would write then is angle EFD. Now note, vertex is the middle letter, is congruent to angle XYZ. A thing is the same size and shape as another thing. They're twisted, but they're still congruent. Now, I can talk about how their measures are equal. The measure of angle EFD, which is a number. Measure of an angle is a number, equals measure of angle XYZ. So a number equals a number. That leads me to the idea that they're congruent, that I can apply this term congruent to them. Now, when I talk about an angle bisector, Here is an obtuse angle. We'll call it PQR. If I bisect the angle by drawing the ray QS, so here I have angle PQR is bisected by QS. Now notice I put the arrow over the top of the QS to indicate it's a ray that's shooting out there and bisecting it. That means these two angles are going to be the same. As we've talked several times already, the word bisector means to cut into two equal parts. That's what I'm doing here. I've got this half and this half. So I've cut it into two equal parts. So whatever number this is 2. Now with congruent angles, and these will be congruent because it's cut in half, we draw arches inside them to show they're congruent. So if I were to get rid of these arrows and put my arches in there, this shows that they're congruent. I might use 2 arches to show those are congruent. So these are congruent to each other, these are congruent to each other, but these aren't necessarily congruent to each other. When you look at the arches, look for everyone else with that number of arches. That tells you what it's congruent to. So again, the vocab words that we would need are congruent, meaning they have the same measure, and bisector, which is a ray that cuts the angle into 2 equal parts. Or you could say a ray that intersects an angle into 2 halves, both to get the job done. So there's our vocabulary. Now let's actually talk about that angle addition postulate. Look at some examples that go with it.